Deadline for week 6 is 1826, no? Yeah, hello Akshay.
Hello, sir. Good morning.
Good morning.
Sir, are you taking doubt session of week 5?
Week 5 is done, no? So we are thinking to take week 6 session because if we take week 6, if no one is there, then we type outside. So
There is only one doubt.
this,
If
yeah, sure, no issues. We'll take that because no one is here. Only Prince and Chandan is here.
Okay, sir.
I'm just waiting. Let the people join, then we'll start something. That would be good. Okay, so let me present my script, then we'll start the session. Okay. Okay, so please everyone, like Akshay have some doubts. So what's your doubt, Akshay?
Sir, in week 5 practice assignment, question number 10. 10.
Okay, so what's your doubt here?
Sir, I didn't understand the even I checked the solution of the assignment.
Mm-hmm.
Let me open
Mm-hmm.
this.
So
So I
if the
was able
range
to.
of
Yes, yes, sir.
in this problem only saying to be the ranges, like if the range of fx and gx are this one and this one respectively, then find the value of m. And so just need to find the range of this one. So what is the range of fx is going to be?
Sir, I understood. Sir, if you open the solution, now you will see that there is 5 by 2 minus
Mm-hmm.
infinity
Okay.
5 by 2 to union 5 by 2 to infinity. So
Huh.
that
So it
part
will
I
be a
have
kind of,
understood.
yeah, because of we have already in the zero is there. Let me see who is here. Okay, so see that as here. Your
Yes,
side
sir.
is raining, Akshay. Is
No,
that
sir. Wait, let me take off the earphone.
okay? So as fx is defined everywhere except zero. So okay,
Sir, it's not
okay. Let's.
raining here. Is it better now?
Sorry. What are you
Is
saying?
it? I'm saying it's not
Uh,
raining. It's better now.
yes, yes. It's better now.
Okay, sir.
So fx is equal to we have two. Sorry, this one fx is 5x plus 9. So as we have in denominator is x. Okay. So that means it is not defined at zero, except that everywhere is defined. Okay, we know it.
Yes, sir.
Now therefore there will be asymptote at x is 0, at x is equal to 0. That means y axis. Okay,
Yes.
anyhow the y axis will be a kind of this one, like we don't know the graph, but at least we know that y asymptote is going to be sorry, y axis this one. If it is x axis, this is y axis, so it is going to be surely a asymptote kind of, or I don't know how it would be, either it will be like this or this. We'll see it slowly when we will try to figure out. And yeah, also in the behavior we need to know. So what is going to be the end behavior as x goes to infinity? Where the fx is going to be? What will be the fx? And as x goes to minus infinity, what would be the fx also? So for the end behavior shows that the function has another asymptote at y is equal to uh, 5 by 2. Therefore, intercept, this is whatever the x is equal to 9 by 5. Okay, when it will be 0, it means fx might changes the sign. Okay, we'll have the value this to this. Similarly, for this range, we have the value this to this. Therefore, this is going to be the diagram of fx is shown in below. Okay, so that would we will see is different. Okay.
Sir, I understood this first diagram,
Mm-hmm.
but the second part, second diagram, if you scroll down,
Here is
this one,
this
minus
one.
3 and 3, I didn't understand how we got this.
So okay, minus 3, and what is the y here? What we have y? Just a minute. Y is sorry. Y I'm saying
Minus
g.
3 and 3, okay, I understood this.
G is root over y square minus 9. Root over y square minus 9. So that means y square minus 9 should be greater or equal to 0, no? So y
Okay, minus
minus
3 and
3,
3, that's how. Yes.
yeah, that's why it is coming. Means this
Okay.
product should be greater or equal to 0. So except that, admin, it means that it is, if it is the lesser than that, then it is going to be not defined there. So that's why the line minus 3 and 3 is going to be a kind of asymptote.
Okay. So root,
So
sir, root is not defined when we find root of 0, but it is not, we don't take roots of negative numbers, but why not 0, sir?
why not 0? Okay, here, okay. No, so it is, so root is, if you see that the, for the line, like it will attempt the y is equal to 3, it will attempt the 3 and minus 3, no? So root is will be fine. Root over minus 3 is, means it
5.
will come as
So
a 0.
you are taking
But
3 and minus 3, no?
yes, we are taking in this
Okay.
problem, we have to take 3 and minus 3.
Okay, sir. And now you will see the further part. We have to
Mm-hmm.
find 2 of m plus n. So they
Hmm.
have taken this. I don't know why they have taken n equals to 0. M
N
is 5
equal to
by 2 is
0.
2.5 because m is 2.5 because it's 5 by 2. But why n is 0? I didn't
N is
understand.
0, no, as because of the minimum value possible, the range is taking, no? So what is going to the minimum? As here the range is 0 to infinity. So what is going
Minimum.
to be, as we, if you see that, what is going to be, if range is 0 to infinity, what is going to be n here then? N is equal to
Okay,
0, no?
so uh, in that graph,
Mm-hmm.
uh,
Yes,
can you open that graph?
yes, yes. Let me open
So
it.
in
Yeah.
that graph, that y is origin is the, I mean, because it is touching at the x-axis, which is the 0. So because at that point y is 0, we are taking it.
Yeah,
And
yeah, because of that, as you are also looking, no, just now said that why we are taking this equal to 0 should be there, because at 3, at minus 3 will be 0. So yeah, that's why the minimum, you can say, the output of even this function, if you have a root over x, so what is going to be output for this one? It will always positive. So 0 to some number or infinity will go, right?
right, sir.
That's why and also if it is the range of this one, so as we need to compare, no, this is in the problem, this is the range. If you compare, then it says n is equal to 0.
Okay, so I was a bit confused. I thought we'll take x, um, the domain, minimum of domain, but it's the minimum of range.
Range, yes, as the root is always greater or equal to 0, root of a
Okay,
number.
sir. Okay, sir. I understood, sir.
Yeah.
Thank you, sir.
Yes.
Sir, how do you
Okay.
know that 5 by 2 is the end behavior?
Okay, so Akshay, can you tell? If you Akshay will tell, then it will be more
Okay,
in your
sir.
word. Yeah, I'm
Uh,
open it. I've already opened it. Yeah,
okay, sir. Just a minute. I solved it a week back. Let me read once. Just a minute, sir.
yeah. Please.
So, perfect defined everywhere except 0, then there will be an asymptote of size. So, can you open the graph? Okay.
Yes,
So, yeah, because it never touches the 2.5, no? If we'll
but that's
put
the
the
problem. Why this is this 5 by 2 is why this 5 by 2 this function is not touching, or why the value is will not get as 5 by 2 or always lesser or greater, why the function will not attempt the value 5 by 2.
okay, so if we'll put x equals to 0, okay, it's 9 by 5, 9 by 5, 5, 5 minus 9, 9 by 5. So I think no matter what value we put in x, it will uh, it will try to attain to this 2.5, but never reach 2.5.
Okay, so we have function fx is equal to this one, no? So now if you see it here, this one, okay, so fx you can also think it like differently also, uh, you know okay, let me tell you that how it is. So 5 plus, if you take 9, this one, and if you take again common, so it would be here 2x, so that means here 2x. So as you are sub, see, we want as x goes to infinity, means where what it means that as x is going becoming a larger and larger, right?
Yes, sir.
So that means this is, if x is going to be larger and larger, say what is going to be with the 9 by x, it is going to be
Zero.
very, yeah, it is very small. It
Small.
is actually coming to very small. So let's cancel out here, as we have both x. Okay, let it be cancelled out, because as x is up and down in numerator and denominator, so finally we have this 5 plus 9 by x upon 2, this we have. And as x is going to be larger and larger, this portion is going to be very small. So that's why you can say as x goes to infinity, the whole value now is how approaching, the fx is very, it is approaching 5 plus 0 by 2. That
2.
means it is approaching to 5 by 2, 2.5. Is it correct?
Okay.
Is it fine?
Yes, 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 yes.
So
But
that's the process. Yeah.
but sir, if
Hmm.
it is being divided by x, it will be close to 0, right? 9 by x. So
9 by x. Yes.
will be close to 0, but it will be
Yeah, it will
positive.
be. Yeah, it will be. Yeah, as x is from positive side is going, means positive infinity. Yes, it will
It
be
will be
positive.
positive. So 5 by it will attain 5 by 2
No, it will not attain 5 by 2. How? Because why it will attain 5 by 2?
because
How
9
you
by
are clear?
x is positive. Matlab, it could be 0.0000 something, but
Yeah,
5
it
plus
could
0.
be. That's why it could be, but we are not sure what is going to be that. It could be. Possibly
Okay.
it will, but
Okay, sir. Okay, sir.
hmm. Okay, just a minute. Okay. So, and also for minus 5 by 2, how it could be? At x is going to be minus infinity. In that case, also again the 9 by x is going to be approaching to 0, no? Very small negative number. It is coming as a, if you substitute here, it is 9 by minus some big number. It is from negative side is coming to be 0. So again, that's why the from negative
Okay.
side, if you are coming a very large negative number, if you are giving it, still it is fx is approaching to 5 by 2. in both cases. Is it clear for both negative and positive?
Yes, sir.
Yes, sir.
Okay. Okay. So let me go with the next. If anyone, this is one. Okay. Anyone else have doubt? Yes. Yes, Chandan. Yes, you are on. Okay, you are on mute, I think. Yes, Mohit. Yes,
Sir,
Chandan.
week 6,
Hmm.
tutorial 4, I have doubts, sir.
Week 6.
Yes, sir.
Okay. Which tutorial?
4.
Tutorial 4. Okay. What is your doubt here?
What is that Sigmoid function that they introduced in the video?
Okay. Okay. Sigma function. Where
Sigmod.
is that? Sigma. No, no, sorry. Can you repeat again? Could you repeat it?
What?
Sigma. Sorry.
Sigmont.
Where is written sigma? All divided gn. Okay, anytime. So find out the logic to separate the point. Okay, assign g and g to each point. No, no, I'm getting. I'm not getting. What's your doubt? Could you repeat, please? Sigma.
1 minute,
Where
sir.
is the sig? Yeah.
So maybe sigmoid function he is saying.
So where is the word written here? Sigmoid. Yeah. Okay. Okay. Here is the sigmoid. Okay. Here is the sigmoidal curve. Okay. This is sigmoidal curve. Fx is a sigmoidal curve.
Yes, sir.
Where is the word came? So sigmoidal curve is kind of no. This is if it is written such type of function is generally called. You'll see in the Google also. No? So such type of either kind of this one. It is like as you know the fx case as fx is new like this. So such type of this see the sigma. There is one function that is don't worry that word, but there is a function e power x minus e power minus x upon 2 is there or another this type this one function and e power x plus e power minus x by 2 and another function is e power x minus e power minus x upon e power x plus e power minus x. So such type of function is actually called sigmoid. It is generally denoting as the sine also sine hyper, which is sine function,
Yes,
sine
yes.
x.
Function. Sin x cos.
So sine x is there. So yes, so there is another function which is sine hx, but it's the it have the expression of e power x minus e power upon something 2 is there or I'm just forgetting that, but such kind of function is actually come under the name is there sigmoid. So don't worry with the word, but yeah, just means to say. And if you see the graph of this type of function, it will be look like this or kind of this. So such type of function is actually sigmoid as here if you see in the video. Okay, here's also drawing it in the Desmos. See how it would be. So if you see this as here the graph, or in other way also we can see the sigmoidal curve is there. Okay, so such type of function as just now said, no, this one as here the curve is in between the curve in between the two lines.
Yes, sir.
Sigmoid function, see this one is as this expression is actually the if you, it is a naming a sigmoid function is a mathematical function having a characteristic yes shape. Yes, which a curve which have a S shape, you can
Yes, sir.
say as a sigmoid curve. Okay,
Yes, sir.
in between you can bound it like it have two asymptote like this type of curve is that you can think as a sigmoidal curve. Also, you can think that tan, tan graph of tan is also kind of this one, but this is not a S shape. Yeah, it is vertically yes. Okay, so how it would be the graph we just name is there. Don't worry with that. The mathematical, what is the behind the math? Is behind that expression or terms or the what is needed for the to solve that problem? That's enough. Otherwise, the word is there. Just sigmoidal is the kind of yes shape which had the curve yes shape, or also I said no this kind of there is a
So,
sine hyperbole that is called sine hyperbolic something is there. No name is there. Yeah, hello.
so
Yes.
can we say that the function that you drew, this tan function and the sigmoid function, so can we say that they are inverse of each other? Because there was one
No, no,
question,
no, not
graphical
in
question.
not in words, not in words. If you see that, that if it is so, see, sigmoid function is as the definition from is just now seen. It is shape of S, so it could be larger, smaller also. Could be from -5 to 5 and -5 to it will run over -5 to 5. But sine is sorry. If you see the tan function, tan graph, sine
Infinite.
graph is it is kind of this one.
Yes,
Tan
sir.
function graph is in between -pi/2 to pi/2. Here the domain is fixed, no? In between these two lines, it's behave like this.
Okay.
And again, there is a range fixed. So this is the domain. This is the domain part. This is the output part, codomain. And here is again 3 pi/2.
And if we draw the inverse of sigmoid function, how would the graph be?
So
Because sir,
okay,
there was this graphical question, and they had asked if whether they both are inverse of each other. And
no, in this problem in S shape, what is going to be the inverse? Is that so for the inverse, as we have, for example, if you take this one, no, this e power x
yes,
upon e power x plus one. If you take this one, okay, e power x upon one plus e power x, then it will come as a log, no, as the exponential inverse of the exponential is come as something is done in the log form,
yes, sir.
right? So, but yeah, for this one, I don't know how we'll find the inverse of it. We have 1 upon 1 plus, okay. So exactly find the inverse is it could be difficult. For this one, how we'll find the inverse? This is one function, fine,
One function.
and the inverse would be 1 upon 1 plus e power minus. If you assume this is y, okay, this is y. We assume it here. That means it could be written as uh, inversing or 1 plus e power minus is equal to 1 by y, and this should be e power minus x is equal to 1 by y minus 1. This is the, if you see the one tutorial is there how to find the inverse, if you or Wixis is done, I think, yes, on this Wixis. So this is, if you take now the log, so this is x log would be here, okay, or generally the base with the same, and this is going to be the log 1 by y minus 1, and the finally x is equal to, log e to e is 1, minus x is equal to log 1 by y minus 1, and finally we have x is equal to minus log
minus log
1
y.
by y minus 1. So the inverse function for, if you see that for this one is going to be for this one, or this one is going to be log minus 1 by y.
Okay, sir.
Okay. Okay.
Yes, sir.
So
Thank you.
anyone else have doubt? Yeah, I think Mohit is have raised hand. Yes, Mohit.
That's it, sir. No doubts.
Sorry.
That's it, sir. I have no doubts.
Okay. Okay. Chandan have some doubt. Chandan is, I think,
Yes, sir.
done. What's your doubt?
Sir, I have conceptual doubt in
What's your?
exponential function and logarithmic function. That
Okay. Huh.
While understanding the concept, I understand everything, but while recalling, I got confused between the graphs of exponential and natural log and natural logarithmic function graph. It seems like
Okay.
mirror images.
Okay. Okay. Uh, so see the natural exponential, you are saying that e power
Yes,
x.
and a logarithmic also, and natural
Okay.
logarithmic.
Okay. So just the definition. Let me start with the definition. The definition is exponential is generally denoted as sorry, a power x. A power x. So such time where a is any real number, you can think it as a is any real number. But if we bound it something in the positive case, that would be good, because in negative cases, if a is any real number, if you assume a is equal to minus 1, no, and x is equal to some 1 by 2, in that case it is going to be root over minus 1. We'll get a complex number. So that's why we need to bound it. Okay. This type, so definition of exponential is this type of function is the called exponential function. But here we need to bound, because of if a is negative, in that case we have some problem, we'll get some a complex number. So we don't want, we want to play on only real number. Input is real number and output is also a real number. So for that we have to bound it here. So in that case we need to assume a is strictly greater than 0 and a is not equal to 1. The reason is, as a is equal to 0 will happen, so it will always, your function is a 0 function. And if a is uh, 1, if you assume, so again your function is going to be a constant function, which is fx is equal to 1. So let's bound it here, and the case is here a is strictly greater than 0 and a is not equal to 0. Such type of function is called exponential function. And now if you start drawing the graph of the exponential, so the graph will be, okay, let it. So I'm assuming, let's say we are thinking we are going to take a function fx, which is a kind of this one, 2 power x. So this is an exponential as the a is equal to 2, which is not fall under this one, not fall on, it is follow this condition, a is greater than 0 and a is not equal to 0. So this is an exponential function. Now as we start, we want to draw the function. So x could be, but here see that here is bound on a only, not the x. X could be any real number. So can you tell me what is going to be the domain of this function?
Real numbers.
For real numbers, because here is, we can give any value to x, it will give some it to the power some number, to the power some real number, which is some value will have, some value, some real value will get always. So here, that's why if you see the domain of the exponential, no, exponential function is always have the whole real number r. Now if it is play the whole real number r, so can we start thinking that if x is very large number, as we can say x is a very large number, what is going to be output? Let's say to the, so in that case your number will be, let's say, to the, to x2 to the power some 1 lakh. So it will be very large number, 1 crore, 1 lakh. So how if you assume x is equal to very large number, so that means your output is also very large number. So it will be look like, okay, it is coming like this. It is as the number we are increasing, as the value of x is increasing, it will also increasing. So the graph will be, that's why it is like this. And if you assume x is equal to 0, in that case it is be 2 power 0, right? So 2 power 0 means what? We can also write 2 power 2 minus 2 differently also, and this is 2, or even also write like 1 minus 1 is also, and it means that 2 power 2, and this tells you 1. So for any exponential, if x is 0, then in that case it is going to be 1. So that means it is true for any exponential. That means at here is what is going to be the y-intercept. Once we are substituting here, its output is 1. And again also start thinking as x goes to minus infinity, what is going to be in that case?
It will
So
be a
our
very
number will
small
be some
number.
a small number. It will be like x is going to be minus infinity, means here 2 to the power some negative number is coming, no? In that case it is going to be negative number. That means you can write 2 to the power x, sorry, 1 by 1 upon 2 to the power x. In that case, and as x is if you are substituting very large number of x, it is kind of negative case. We divided as we change in the denominator in the 1 by form. Now again it is going to be very large number, so 1 upon is going to be very small number. So that means this line, so as it is increasing to minus infinity means very small number, then it is actually coming to 0. So the graph of exponential is actually this one. This is the graph of exponential. So this is the case for any a is, but here is the case for a is greater than 1. Here is the, this graph is for the case of a is greater than 1. If a is a is less than 1, in that case the graph is this one. This side will come as, the graph will come as this side. If a is greater than 1, the graph will be this one. Okay? The graph will be this one. And if a is less than 1, in that case the graph would be this portion, this. And these two things we have for any exponential. So this is for 2x is also work. Okay, this is 2 to the power x will also, the graph would be like this. For any exponential, the graph would be similar to this one. Either it is 2x, 5x, even 1000 we will say. Yeah, if you assume 1000 to the power x, so still it will pass through the point 1, 0 1, you can say simply, or here is the output 1. So it will be always the graph for any exponential, the graph will be like very similar to this one. Okay? And if it is, this is the case for a power x where a is greater than 1, and if it is a is less than 1, in that case the graph would be this one. Okay, this side, no? This one. This is the graph for a is less than 1. Now for the, now the case as we have a power x is exponential, the inverse of this function we know that log base a x. This is the inverse of this exponential is logarithmic, if you've gone through the lecture. So in that case, if we assume a is again greater than 1, so the inverse, the graph of the inverse is actually, if you have the graph of inverse is this one, and this is the line y is equal to x. So inverse, graph of the inverse function is what? It is symmetric about the line y is equal to x. This is the line y is equal to x. It is symmetric about the line y is equal to x. So how it would we
Mm.
look like? So see how it is going with this line, how it's we have.
It will be the
It is
mirror
actually the
image,
same
no?
as, sorry.
It will be the mirror image.
Yeah, it will be the mirror image. So as here this one, if you try to mirror of this y is equal to, or sorry, a to the power x, if you try to make the error with respect to this one, how it would be? So see that this is the line, and as we going to this side, it is actually far, and this side is closer to closer also, this like this. So and there is one bound is becoming because of this line, as this is the bound becoming. So similarly this line is going to be makes a bound. Okay, and as here this is intersecting at 0 and 1, similarly at here at 1 it would be. So as the symmetricity is there, no, with respect to y, so at 0 1 this is this one, so here it will be 1 0, right? At 1 the value will be 0, output will be. If you see that the graph of log e to the power x is the similar to the, it is symmetric about the line y is equal to x. So this is the log of a to the x, as here we have, but this is the graph of a to the power x. Here is the case for a is greater than 1. Now for a is less than 1, the graph of exponential is what? Is this one, no? This one. And let's draw the graph of y is equal to x. The symmetricity happen with respect to the line y is equal to x. So again start doing. So inverse of this one is again log with base a, but here is a is less than 1. So how the graph for less than 1? How it would be? So let's see that how it is. This is the line we have, okay, and
Both
with
graph
respect to
will
this line, as this side it is going to be the far away, as if you see this side and this side, it is going to be a far away kind of thing. So similarly how we will form for y is equal to x, the symmetricity will happen with this case also. So as this side is going to be far away and this side is going to be far away, so this is will come, no, it is going to be this sign and this side. So it will become like this. So this is the case for minus. And again, as here is going to be 1 0, sorry, 0 1. Here is also going to be 1 0, just symmetricity. And yeah, here is very difficult to observe the symmetricity with respect to y, y is equal to x line. But yes, the graph would be for the log case when a is lesser than 1, the graph would be like this. And the exponential for the a is less than 1, so exponential is, we have this one. Okay,
yes, sir.
is it clear, Chandan? We discussed, I
Uh,
don't know.
yes, sir. Now it's clear, but on the exponential graph you have
Mm-hmm.
made initially,
Mm-hmm.
in that her condition that a equal greater than equal to greater than 1,
Mm-hmm.
then what will happen if a is equal to 1? Is there that the function will be not defined?
No, no, it is in that case, it is kind of a constant function, no? So in that case, it will be a constant function, but we want to play something, no?
Yeah,
If it
yeah.
is
If
1,
1 to the power anything will be 1.
if anything, anything to the power 1, or 1 to the power anything, it will be always 1. So,
Yes, sir.
but we
Or
don't want that. Yeah.
if a will be negative, then what will happen? Graph will be inverted.
Yeah. Is negative still for 1, it is the same as, no? It is 1 upon 1 become and some number. Still, it will be the same 1 will give.
Hmm.
So for any, for this is for the case 1 to the power some number is always 1, which is a constant function. Okay? In that case, we have some problem. So sorry, in that case it is will be a constant function. That's why we are not considering, and we want to play some variable and some output is there, but it is a constant function. So that's why we are neglecting the case for a is not equal to 1, and for negative case we just now seen that it give a some complex number output, so that's why we are not going to consider. So the cases is a is greater than 0 and a not equal to 1. In that case we will see the definition for the exponential. Okay.
Okay, sir. And sir, the graph of a p power x, where a greater than 1, and the graph
Mhm.
of e p power x will be same.
E power x, huh? Okay, the graph of it, yes, e is also a real number, no? So e is coming as the same case. The case as a is greater than 0, a is not equal to 1. In the same case, it is coming, no? E is something, some irrational number, 2.3 or something is there, no? Some irrational. A is actually greater than 0. The same case is happening. Even a is greater than 1 also. So that's why the e power x, the exponential graph is the same as the a power some number a is greater than the very exactly not same, but yeah, it is look like the same e power x also.
Okay, sir.
Okay.
Okay. And sir, one more doubt that if we have seen that a greater than 1 and a lesser than 1 conditions, what will
Mm-hmm.
happen if a is between 0 and 1?
So that's why a is G2, yeah, so a is lesser than 1. That means the case will happen. No, a is lesser than 1 means a is always positive. Always the case thing that a is always positive. If it is negative, then that would be problem. So a is lesser than 1 means it is falling in this range. So in that
Mm.
case, your exponential is converting in the different way. It is as for the positive case, sorry, a is greater than 1. We have this case, but a is lesser 1, then in that case it is going to be this one, no? Also why it is happening, as a power x is there, no, and a is less than 1. So could you think that if a, assume that a is 1 by 2, okay, if a is 1 by 2 and we want to find the 1 by 2 the power x, and assume x is very large number here, this means x is very large number. So what is going to be in that case the value here? It is going to closer to 0, very small number, no, it is approaching to
Yes.
0. So that's why see the graph, it is as it is going to be increasing, the value is also closing to 0, no, y is equal to here is 0. It is
Mm.
actually closing to 0.
Yes.
And in
Okay.
the case of negative, in the case of negative, how it would be, or you can say as x is going to be minus infinity, so in that case 1 by 2 power some a power sorry 1 by 2 power x, as x is negative, in that case how it would be,
2 to the
it is going
power.
to be very large number, no, very large number, as it will convert as a to the power x, because some negative is there. In that case it will convert it as 2 power x, and x is again the very large number, will give as very output as very large number as x is increasing. So if it is the negative case, then it will be approaching to positive infinity, correct? So that's why the
Mm.
graph, you see that how it is going to be the positive, very large number. As the negative side we are approaching, it is the output is going to be very large number. That's why the graph is this side.
Yes, sir. Okay, sir. And sir, I have another doubt in graded assignment 5. Just a small doubt. Can you clear me?
Okay. Uh,
Graded assignment 5, question 4.
so graded is DODS is today of week 5, no?
Hmm.
Okay. What's your doubt?
Sir, I have doubt in the initial steps. I will solve it by myself. Just initial steps. I have doubt.
No, so I will suggest you. We are not going to discuss that, but yeah, if you have the doubt in the problem you are not getting, then we can discuss.
Okay, sir. Sir, the question is like decaying the radioactivity.
Yes, yes.
I have thought that the equation in the question will be in exponential or logarithmic.
So, see, you are studying for the exponential, no?
Yes.
So, till now, week 5, we didn't study about the logarithmic. So,
Okay.
that means the whatever you will get in the exponential form, no? Logarithmic
Okay.
is come under the week 6.
Okay, sir.
Okay. Okay. Okay, so okay. Anyone else have doubt? Okay. Okay. So anyone else have doubt? Please let me know. Or we're not going to run much longer. Yes, no, no, waiting for join. Yeah. Okay. Anyone else have doubt? Or please let me know. Or so let me tell you the about the week 7. Uh, in week 7, we are going to study uh, about now the week 7 is calculus portion. Calculus in the sense of like here you will study uh, limits, continuity, differentiability of any function. So here in uh, this week we have about the limit of sequences and uh, limit of uh, function. Yeah, even though these two are limit of function we have and the limit of sequences. This lecture we have, and we have the tangent thing. So all of you gone through the week 7 lecture?
No,
No,
sir.
sir. Sir. No, sir. No, sir.
No, sir.
Then then I think
I mean,
let
can we have a
me.
summary of like week 6, sir?
So summary is like if it is the larger people you hear, that would be good. So yeah, we can do that. We'll quickly do that.
Yes,
Uh,
sir. It is after qualifier, no? It is after qualifier, yeah. People will less.
so okay, so in okay, so yeah, okay, we'll quickly finish it. Okay,
Sir,
uh, what is the in week 6 we have?
okay, sir. Thank you. Yeah.
Okay, so let me finish it. Uh, so so in week 6 we have the logarithmic function. Okay, log function. And log function is actually, if you say that is log function, if you say that the mathematician have derived it, you can simply say that how it came. So they first thinking such kind of function, exponential function. Okay. We have suppose exponential function 2 power x, 3 power x, 5 power x, or 2 to the power 5. Because of this power thing, no, they started thinking uh, it came, like how they what about once they know that we have the such kind of function fx is equal to a power x, then can we think about, can we get a inverse of this function? Because as we have seen that in week 5, yeah, in week 5 we started, we have something about the inverse of some function. So can you think about the inverse of exponential function? So that's the, from here, thinking about the inverse of function, that's why the log came. So if you assume this one, okay, this fx is equal to a power x, so what is going to be the inverse of such function? So simply in other way, let's say, or let's assume this is y is equal to a power x. Okay, so what is going to be here, or simply what we can do so that we can revert it, what is going to be the inverse? So if you see, the logarithmic function is actually created one with the exponential. It is not actually, it is like as sine is came, sine cos other 2 power x, or polynomials came, it is, you can think it is automatically came, but log is actually created with the exponential. As we know, we have the exponential, and exponential function is increasing, continuously increasing, and one function, so it is actually invertible. So what is going to be the inverse of that? So in that case, the log function is came. So we have, the, if you have fx is equal to some 2 power x plus 5, if it is suppose this is the function and we want to inverse it. So what is the inverse? The inverse we generally denote with the f minus to the power minus 1. Okay, and if you do that, f inverse, if you take the composition with the f, it is actually identity function you will get. That's the meaning of inverse. That's the meaning of inverse. So similarly, what we can do here, let's assume, see, as this one we know that exponential is increasing and 1 1, so it is invertible. So what is going to do with this function? What is we'll do here with the composition, so that we'll get identity with the same case exponential. So this is f inverse, and this is fx is going to be, this is could be written as fx, and this is exponential. Sorry, this is x. So this is f inverse a power x equal to x. So what we can do here, what is going to be right here in place of s inverse, so that it give the identity function x. So that's why here is created that, can we think a function or can we create a similar notation? This is kind of notation. No, what the word means log is actually, it says that log, okay, log of x. Also, before that it is, okay, so this is the story behind why the log is came. Okay, this is the story behind log is came, and how we'll write here, so that we'll get identity if you compose with the fx. Here's the meaning of fx. So that's why if you see that the log is actually a, and again, if we know that inverse of exponential is bit know something, know that, okay, let's assume some function is there, the notation of the function is this one, and we compose with this one and we got the x. So log with base a is, you can say, the of inverse of the exponential. But if you see that how the exponential is also written, no, if you have this log is written, if you have 2 to the power 5 is equal to y, what it mean that? It means that 2 to the power y, 2 to the power y is equal to 5. This is the meaning of, right? This log meaning is this one. So see that the logarithmic is actually converted as the exponential. So similarly here, if you see that this base is actually the same base, and this here the exponential output become the input of this log, and input of this exponential become the output of the log. See that this is the creation part is happening. That's the log here. This is the log function. Okay. So simply if you see that the log is nothing but the exponential of the logarithmic function is the inverse of the exponential, and if you have if it is written in this format, okay, if it is written, let's say this is y, then it means that it is 1 1 correspondence. That means if you have this one, no, so this one could be written as y a to the power y. This is the meaning of log. This is one thing. And log function have some property. Okay, the function, the property of log function is, if you have m and you multiply it with the log n, so this is could be written as log, oh sorry, not this one. What is the property? Log m into n is log m plus log n. So there it have some property. This is the log a to the power some n is there, then it could be written as log, in the multiplication we can write it here, and if it is written as log a by b, then it could be written as log a minus log b. And this is the third property. Fourth property is log, if you have a to the power a, here is the any base, no, here is the any base. So, let's assume for this is the base 10. So it is true for any base. Okay, not even the 10, it is more than that, you can say. So assume the base is here 1 by n, or even let's say this is n. and this is m here. So this could be written as 1 by n log am. So this power of the base become the denominator of this whole 1 by n, or even you can write here also n. So this will become 1 by n log e to the power n. And any other property? Um, log. Okay, that's all for log properties we have. If I've got some remembering, I will get some property, then we'll discuss that. So this is the property of log, okay, and this is the, this is the relation between the log and exponential. We can actually one correspond is there. If you have log with this some number, you can convert as a exponential also. This is the relation we have. Now let's back to the graph of the log. So graph is, we'll see it here on Desmos. So again, we just now, as we discussed about the graph of log. So log with the base a of x. If you see that the slider came here. See that for the lesson case, for the negative case we don't have. Okay, for the negative case we don't have. Here is, we can give as bound here is greater than 0. Yes. Okay, so here is bound is that, okay, here is given it is going to be 0. Okay, so the graph for logarithmic is, as we have the exponential is says is, we have, for the exponential case we have two type graph. The cases is, we have, if we have exponential a power x, and suppose your a is greater than 0 and less than 1, okay, in that case the graph is, this one. This is the graph for the case of, we just now discuss, so that's why I'm leaving the part of the drawing the graph for the exponential, even the, because earlier we are actually discussing about the graph. So how it is coming will already have, we have already seen that. So the, for the case of a is lesser than, the exponential graph is this one. So similarly, we can get for the log function when a is lesser than 1. In that case the graph is exactly this one. And for a is greater than 1 case, the graph of exponential is this one. So the graph for log with base a is going to be this one. So I am not going to discuss, because I spent much time earlier on the graph of logarithmic and exponential also. So this is the case for when a is greater than 1, and this is the case for a is lesser than 1. This is these are the graphs, and this work, this whatever the a will be, a is, see, we are categorized here. So a could be, now a is greater than 1, a could be 3, 4, 5, even 1,000 crore lakh, whatever the, but graph will be very similar to this one as this one. So a could be anyone. Okay, for the, if it is a is 1,000, so log 1,000 base to the x. So if you draw the graph, it will be very similar to this, the same graph. So that's the meaning here. Here is the, we are, here is the mathematician have categorized, if a is lesser than 1, the graph will be differently look, but a is greater than, the graph will be looks differently. So this is the graph of logarithmic. Okay, and now, so what is the use of this logarithmic function? So 1 minute, let me see what are the other things we have. There is not much in the log we have. Now the logarithmic function is actually will help us to solve the logarithmic equation, and or you can say yes, that's all. The in the logarithmic equation we have a logarithmic property. So logarithmic property will help you to solve the uh, exponential problem, or logarithmic equations or exponential equations. So suppose, for example, if let's take, I'm taking this one. Okay, suppose, or here is not equation. This problem, I think so. As here is, suppose we have x and y are positive real number, which is the log with base x2. This one we have. So then which of the following options are true for the log? So suppose we have this expression, okay, log x with base 2 plus log, okay, so y, and this is it. So one property also we need to write here. That's why here is one property is needed. The fifth property, you can say. The fifth property is log with a base a and b value could be written as also 1 upon log base change. Now that this, whatever the inputs we are giving, it is become a base. Okay, so this is the changing, this is the base change, you can see. This is one property. So this property I am going to use for this problem. What is going to be this for this one? Okay, so this is could be written as, we know, as this is, we can change it here. This is become 2x, sorry, this is 1 upon, this could be written 1 upon base 2 with 2x, and similarly this will become log 8 by. So see, the problem is whenever whenever we have some equation, whenever something we have, we will try to we will try to make the same base as here. What I am trying to do, I am trying to make the same base here. So how we'll make it here? So see that here is 2, here is 8. Previously it was x and y, so there is a problem with the same base. See, this property, all property, whatever we did here, it will, we are able to play with the same base. Here is also with the same base. Whatever the addition, multiplication we are able to do with the same base. So we needed to make the base is same. So previously it was the variable which is also different, 2 and 3. But now we change it to some number, constant number. And also again we will do something here. This is 1 upon log x, log base 2 plus 1 upon log, this 8 could be written, 8 could be written as 2 to the power 3. So 2 to the power 3 y, right? So this could be again log 2x plus 1 upon. Now we have the property, no? The property is to a to the power n. If it is b is there, then 1 we can write 1 by n log ab. Right? This could be written. So that means here we can write 1 by 3 log 2y. Now see that anyhow we will try to make here the base is same. Okay. Now here is what we can do the next. Here we can write it here 1 upon log 2x plus 1 upon, see this is 1 by 3, no? So log with base 2, and this is, we can write, see we have another property, no? If a is, yeah, in the sixth property we missed that here. So sixth property is, oh no, here is that, yeah, this is already there. So this we will use this property. If a b to the power n, that means n log ab, we can write like this. So if you have in this format, we can back to this one with the same. That means here is 1 by 3 we can write, no? This is 1 by 3 is there, so we can write here 1 by 3. So this is one. Okay. Now what we can do, we can now we can take the, right, log, you can take the as a, doing how to solve the some rational numbers. we'll take the common, or we take the LCM of it. So log 2x into log 2y to the power 1 by 3, and we can write like this here. Log 2x plus log 2y to the power 1 by 3, and we have no log ab plus log mn. This could be written so same with the same base here. A is n. In that case, they will be added, b plus n. So here is the same base, we can add them. This is log 2x plus, sorry, here is multiply. No, in the multiplication we can multiply, could be separated. That is x into y to the power 1 by 3 is the log base. I think I am missing something. I got the different approach. That's why we are not reaching to the solution. But yeah, we are actually playing around the property of the logarithmic. Yeah. But for that we have to no. It is actually here is 0. Okay, so we are actually on track. So this is the right side. The left side we played here. The left side. This is left side we took. So finally, the right this right side is actually 0. So we are took the left side and solved something and reaches to here. It reaches to here. And now take the left hand side is this one, and let's equate it to 0 at left side is equal to 0 we have. That means here it would be now if you multiply with this side, as you know, with the how to deal with the fraction, so this will become log with base 2 x y to the power 1 by 3 is equal to 0. If you multiply with 0 with this denominator, it will become 0. Now here we have this is 0. What it mean that? Now I want to know from your side what we are going to know the next. When we have output as 0 for logarithmic,
Sir, log 1.
log 1. Just a minute. So here is, that means here is going to be 1. That's why we got output as 0. That means xy to the y to the power 1 is going to be 1. Now if you see that here, this is something we have. Okay, so here is 1 by 3 is no. But here we reaches some, okay.
Yes,
Which is
sir.
satisfied.
Q on both sides then.
Yeah, actually this is correct, as we have some equation. Now we need to compare with the option, which option is actually satisfying that one. Okay. I think I'm missing somewhere. This is x is equal to 2, y is equal to, this is correct. And is this equation is satisfying that one? The second option is correct, as here we have, so we have the equation finally, x y to the power 1 by 3 is 1. So which one is satisfying this one? Yeah, so this could be written as x is equal to y to the 1 upon 1 upon y 1 by 3, and 1 by 3 is, if you multiply with the 3 in the, if you take the uh, power of 3 both side, or finally, or even you can say that if you take the power of both side here to the 3, it means here and 1 to the power 3, that means here is x cube y is equal to 1 to the power 3, which is 1. So this one, or whatever we solve, this could be written as this way or this way. Okay. So this is the property. We uses the property and reaches some conclusion. This is the log, and for this session, I'm now something we have discussed. I'm stopping it here. The summary thing. If something will remain, we have already for the session of week 6 is on. Yeah, week 6 is this one. Yesterday there was session. Today we have session, and today is actually for week 7 we have, but we have discussed a lot about week 6 only. So no issues. So these are the property we have. Using this property, the logarithmic property, whatever the we have logarithmic property, we will use that, and using those all property, we'll try to solve the exponential equations whatever we have as we solve. That's all for this logarithmic. This is the only. If you see that in lecture, in each lecture, only sir have solved the problem using the logarithmic property. This one, or even this one application also. 3 lectures are totally based on the use of the logarithmic property. And about the logarithmic function, we just now, if you know the graph of logarithmic, that's all for enough to know. So here is also the fourth, another lecture is also solving the logarithmic problem only on using the exponential problem using the logarithmic. And the graph is that's all about this in the log function. Drawing the graph, know about the graph and how to use the logarithmic function. That means application of the logarithmic function. And what is the logarithmic? Logarithmic is nothing but the inverse of the. Okay. So that's all. If anyone had doubt, please let me know. Otherwise, I'm now thinking to close the session because there is not much crowd, but we have still discussed more about. Okay. Anyone else have doubt? Yes. Okay. Okay. So that's all for today. Thank you so much for joining. The for week 7 content, all of you are not watched the event. The thing is, so please watch now. And also we have session is today also that we have discussed a lot more about week 6 only. So the calculus portion is remain. So please watch the lecture of
Sir,
week
sir,
7. Yeah.
was there any open session done for week 6 contents? I think there
Yes,
was
we
none,
have.
or am I missing it?
Yeah, no. Yesterday we have, but again
Week
the same
6.
as here today's attendance. Even the very lesser than 13 is there. We have open session. So on week 6 we had already done 3 session on Wednesday, on
Who
Thursday,
is it?
and Fridays we have combinedly taking week 6 and week 7. So as here we just now we lot more discussed on week 6,
Okay.
and week 7 is still remains. So I'm not going to start week 7
Oh,
because
yeah.
one is the very less people is here. Yeah. And second is
I
all of
understand,
you are
sir.
not watched the
Yeah.
till now the
Yesterday there was a
content of week
session.
7.
Sir,
Yes,
what is the
yesterday there were a
YouTube
session. It
link
is
for?
already. Huh.
Where is the
Yeah,
YouTube
well,
link, sir? I
YouTube
don't
link
see
is
it
not
here.
there. Actually, yeah,
Yesterday is
it is
not
actually
good.
for weeks. Yesterday we don't have a YouTube link because it is one thing we have like this. Let me tell you that this session on 19 we have a session, but it still need to upload YouTube link because it is just a recorded session. Still, it is needed to upload. I have given
Okay.
the studio to. There is a issue happening with the Zoom link. Zoom actually. Okay, so
Oh,
that's
okay.
why our session is happening on the Meet only. But soon you will get the
Uh,
link for this open session or activity success first session on here. This session is not even recorded, that's why it will not come in the YouTube, because yesterday very less people are there, and also we didn't recorded that, we just took the doubt and that's all, the closes the session. Today on week 6 I have recorded, so you will get the link of YouTube soon. I will again give the YouTube personal team, and it is, you will get the word of it.
Okay, sir. Thank you.
Okay,
Thank
please
you.
everyone watch the session of, yeah, watch this. Watch the week 6. Sorry, week 7. Try to solve some problem, and please join on Saturday, on Sunday we have session, which it will take, and naturally he will talk the whole content of week 7 if you see there. So it's better to always watch the lecture then join the session. That would be very nice, because then you will get, if you have doubt, then the doubts will created when we will start discussing, will come in your mind that okay, this is the I have seen, this is the I've seen. So better to always, whenever you are coming to session, at least watch the sessions, at least lectures should be watched. We are not solving activity practice, it doesn't matter much, but at least solve the, if you at least watch the lecture then come to the session, that and then it's will always good to be discussed, and whenever we are discussing we'll catch that also. Okay,
That's right, sir.
so that's all.
Yeah.
Thank you so much. Yeah, thank you so much. And also once the
Yeah, and
week
please tell
6
them
will
to
be over,
upload the
then we'll
YouTube,
give a
sir.
mock. Yes, sure, sure, sure. And also, we have going through the TA session. No, if you have any doubt, no, each day we have session. So today we have TA session. He will tell you more about. So this is one session we have. So every day we have session. Yesterday were also from 6 to 8 the TA session also, and open session with the instructor. So each day, even the Saturday we have also. You can ask on Saturday with the TAs. So also, like each day he
Yes,
can
sir.
also solve
I
your doubt
always
if you
ask
have
them.
activity practice any kind of doubt. Thank you so much. Uh,
Thank you.
have a nice
Thank
day
you.
to
Thank you,
all
sir.
of you. I'm closing the session now.
You too, sir.
Thank you. Thank you.